Good day, guys. So today we have this question here that is based on the proportionality theorem. Now we have to prove the proportionality theorem. So let's read the statement here. It says that in the diagram below, to prove, so we have to use the diagram below to prove the theorem that states that a line drawn parallel to one side of the triangle divides the other two sides proportionally, right? So that's what we have to do. So now we know that we have to make constructions, right? We have to make constructions. So the very first construction that we are going to make, we are going to construct, BE and DC, right? You have to construct BE and DC. By doing so, when you construct BE, let's construct BE. So just note, when you construct BE, we are now going to have triangle. What triangle? BDE. So can you see triangle BDE here? That's the triangle that we are going to have by making that construction. Then another triangle that we are going to have, and then please note that this triangle BDE, it is an obtuse angle. It is an obtuse angle because one of its angle is greater than 90. So now when we construct the height, we are going to construct it externally. So right, we are going to use FE as our height. So in this case, we don't have to construct the perpendicular height, right, because it is already constructed for us. So one thing that we should know is that for this triangle, when we construct or when we use the height, we are going to refer to FE as the height, and then BD is going to be our base, right? So now let's just erase this part here. Then we now know that that's an obtuse triangle. Then we are going to have another triangle again when we now construct DC. Okay, so when we construct DC, so this is what we are going to have when we construct DC. So when we construct DC, we are going to have triangle DEC, which is also an obtuse angle. So since it is an obtuse angle, we know that when we want the height, we are going to now construct it outside. So since it's now already constructed, that height we are going to refer to DG as our height, right? So that's what we know from this triangle so far. So we have constructed BE and DC. So remember that you should always show the construction statement where you have to show it. Normally for proofs, always indicate your construction. So this is called the construction statement. This is required. So in a case whereby you didn't write this but then continue to prove everything right, then that will result into a 0. So that's how important the construction statements are. So now let's move on to this. Now we want to find what the area, right? The area or the ratio of the area of triangle ADE over the area of triangle BDE, right? So let's do that. So now we have to find the area of triangle ADE over the area of triangle DEB. Now we want to find the area of triangle ADE. Now treating AD as a base, so we are going to have half times our base. Our base in this case is going to be AD. Now when we take AD as our base, what is it that we are going to have now as our height from triangle ADE? It means that FE is going to be our base. Remember, the height has to be perpendicular to the base, right? So now let's move on to the next triangle. Our next triangle here is triangle DEB. Now you notice that triangle ABE, as we have said, that this is an obtuse triangle. So now when we still now calculate the area of triangle DEB, this is going to be half times the base. So now our base is going to be BD. So since our base is BD, remember that our height has to be perpendicular to the base. But then since this is an obtuse triangle, it means that our base is going to be externally constructed. Then that height there, it's going to be FE as well. So it's going to be FE as well. So we are going to have this. Remember, 1 over 2 is going to divide with 1 over 2. You're going to get a 1. Then FE is going to also divide with FE. You are going to get a 1. So that's what we are going to have there. So you have 1 over 2 and 1 over 2. You are going to be left with 1. FE and FE, you are going to be left with 1 as well here. So now this gives us that AD over BC. Right, so that's what we have when we deal with the first triangles now. So now the other triangles that you have to focus on now, it is triangle ADE still, but then now we are going to be using base AE. And the other triangle that we are going to be focusing on here is triangle DEC. Right, so let's do that. So now we are going to have that the area. So the area of triangle ADE over the area of triangle we said we are going to now focus on triangle DEC. So now DEC, then this is going to be equal to, so now let's go back to the diagram. We know that the area of ADE is going to be half times the base. So the base that we wanted to focus on triangle ADE, now we want to treat this one as our base. So we are going to write AE. So now since we will have to treat AE as our base, then it means that DG is going to be our perpendicular height. So we are going to write DG here all over. Then we're going to have 1 over 2 for this other triangle here times the base. The base of DEC is going to be EC. We are going to use this one as our base, and then if we use this one as our base, knowing very well that this triangle here, triangle DEC, is an obtuse angle, we know that the height is going to be externally constructed. So if we use EC as our base, so we're going to use EC as our base, then this is going to be multiplied by our height. Our height in this case, because it's already constructed to for us as DG, then we are going to have DG here. Going to have DG, then this is going to be just like the same one or the previous one here. We are going to have 1 over 2 that is going to divide with 1 over 2. We're going to get a 1. DG divided by DG, we're going to get a 1 as well. So when we multiply those 1 with AE, you're going to get AE, right? Then when you multiply those ones again with EC, you're going to get EC, right? So now, so we are almost done with this. The only thing that you have to do now is to now go back to this. So now focusing on triangle DEC and triangle BDE, triangle BDE and triangle CDE. Those two triangles, let me just highlight these triangles that I'm referring to. Triangle BED, can you see BED, and also triangle DEC. Alright, these two triangles here, we can see that these are triangles that are within two parallel lines. So since these two triangles are within two parallel lines, we know that they are going to have the same altitude or the same height. This is because now two triangles that are inside, or it's because now the distance between two parallel lines is the same, right? So that will be the perpendicular distance from BC to DE. It is going to be the same throughout, right? Because these are parallel lines. So this is why the height of the two triangles is going to be the same, right? So now what do we have so far? Now we have the same height, right? Then if we look at the same triangles again, what do we have? We have the same base. We have the same base, which is the same base, which is what? DE. The two triangles have the same base, which is DE. So now we can see that we also have what? The same base, which is DE. Then now how can we use that? Remember now, let's now have a look at this. So remember that the area, when you're calculating the area of a triangle, we use the base and the height. The base and the height. Now what is it that is going to help us? So now we have the height here. We are saying that the height is the same for these two triangles. It means that this is the same. Then the base as well is the same because they share the same base. So now what's going to happen? The area of triangle BDE is going to be the same as the area of triangle DEC, right? So we are going to say what the area is, the area of triangle DEB is equals to the area of triangle DEC. Now why is this? We have just said that these two triangles have the same height. Since they are inside two parallel lines or within two parallel lines, so they are going to have the same height as well. And also they have what here? They also have the same base because they share the same base, which is DE. So we say same base here. So that's what we are having. So these two triangles here, they are sharing the same base and height. So now how are we actually going to use this now? So we know that this is equal to this. It means that this here is equal to this. Now we can already see that AD here is the same as AD here. So how are we going to now use this? We are now going to conclude that since DEB and DEC are equal, it means that the ratio of triangle this ratio of area of triangle ADE over the ratio, the area of triangle DEB is going to be exactly the same as what? As area of triangle ADE all over this. This is area of triangle DEC. Then now what are we going to say? Remember that we said that this ratio here is equal to this here. So we are going to have that AD over BC is equal to AE over EC. Remember, this is what we got for this one, this is what we got here. So that's how we prove the proportionality theorem. So this is showing what? Proportions, right? So remember, when we are now having two ratios that are equal, this is showing us what? Proportions. So that's how we prove the proportionality theorem.